Imagine peering out into the vastness of space, searching for answers to the universe's biggest questions, only to realize that half of everything you expect to see is simply missing. If your universe looks like it's missing half its stuff, you're probably an astronomer. For decades, scientists have been on a cosmic scavenger hunt, trying to account for every atom, every particle, every speck of matter that should exist according to our best theories. But the universe, as it turns out, is a master of hide and seek. For years, scientists were stumped. Where did all the ordinary matter go? This wasn't just a minor accounting error. We're talking about the very building blocks of stars, planets, and people. The kind of matter you can touch, see, and feel. The kind that makes up you, me, and everything we know. Yet when astronomers added up all the visible matter in the universe, stars, galaxies, gas clouds, planets, they came up short, way short. It was as if the universe had played a cosmic magic trick, making half of its ordinary matter vanish into thin air. Spoiler alert, it was hiding in plain sight, but before we get to the big reveal, let's rewind and set the stage for this astronomical mystery. Most people have heard about the mystery of dark matter, the invisible stuff that makes up most of the universe's mass. But here's the twist, even the regular atoms, the protons and neutrons and electrons that make up everything we see and touch, were missing. Scientists call this baryonic matter, and it's the stuff that forms the stars that light up our night sky, the planets that orbit them, and the very molecules that make up life itself. Yet when astronomers tried to tally up all the baryonic matter, they found only about half of what the Big Bang theory predicted should be out there. According to the math from the Big Bang, we should see way more normal matter than we do. The early universe was a hot, dense soup of particles, and as it expanded and cooled, those particles combined to form atoms, which eventually clumped together to make stars and galaxies. The cosmic microwave background, the afterglow of the Big Bang, tells us exactly how much ordinary matter should exist. But when we look around, we only see about half of it. The rest seemed to have disappeared without a trace. Turns out, about half of it was just gone. Not in black holes, not in dark matter, not in some alternate dimension, just missing from our telescopes and our surveys. This was a problem that kept astronomers up at night, poring over data, running simulations, and scratching their heads. How could the universe lose track of so much of its own matter? The search for the missing matter became one of the great detective stories of modern astronomy. Teams around the world launched ambitious surveys, built ever more sensitive instruments, and developed new techniques to hunt for this elusive stuff. They looked in galaxies and clusters of galaxies and the vast voids between them. They checked and rechecked their calculations, wondering if they'd made a mistake, but the numbers always came up short. So, where did it all go? The answer, as it turns out, was both simple and incredibly difficult to prove. Astronomers began to suspect that the missing matter wasn't gone at all. It was just hiding in a form that was almost impossible to detect. Not in stars or planets, but in vast, diffuse clouds of gas, spread thinly across the cosmic web that connects galaxies together. Astronomers thought it might be hiding in the WHIM, the warm-hot intergalactic medium. This is a mouthful, but it's basically a network of incredibly thin, incredibly hot gas that stretches like an invisible web between galaxies. Imagine a spider web, but on a scale so vast it connects entire clusters of galaxies, and so faint that it's almost impossible to see, even with our most powerful telescopes. The WHIM is made up of gas that's millions of degrees hot, but so spread out that it emits almost no light. It's like trying to spot a single wisp of smoke in a hurricane. For years, astronomers could only guess at its existence based on computer simulations and indirect evidence. They knew it had to be there, but actually finding it was another story. But this stuff is so faint it was nearly impossible to spot. The WHIM doesn't shine like stars or glow like galaxies. It's almost completely invisible, blending into the darkness of space. Detecting it required not just powerful telescopes, but also clever new techniques and a bit of luck. So how do you find something that's practically invisible? Astronomers turned to one of the universe's brightest beacons, quasars. These are supermassive black holes at the centers of distant galaxies, gobbling up matter and blasting out intense beams of light that can be seen across billions of light years. By watching how light from distant quasars changes as it passes through space, astronomers found subtle fingerprints of this hidden gas. As the quasar's light travels through the WHIM, certain wavelengths get absorbed by the gas. leaving telltale absorption lines in the spectrum. It's like shining a flashlight through fog and seeing which colors get dimmed. These absorption lines are incredibly faint, and picking them out from the noise is like finding a needle in a cosmic haystack. But with enough observations and by stacking data from many quasars, astronomers began to see a pattern. The missing matter was there, hidden in the WHIM, just as the simulations predicted. When they finally detected it with X-ray telescopes, the missing matter mystery was solved. X-rays are key because the WHIM is so hot that it emits most of its energy in the X-ray part of the spectrum. Specialized space telescopes like Chandra and XMM Newton were able to pick up these faint X-ray signals, confirming that the missing baryons were hiding in the cosmic web all along. This was a huge breakthrough. Decades of searching, theorizing, and doubting finally paid off. The universe hadn't lost its matter, it had just hidden it in the most challenging place to find. The discovery not only solved a major cosmic mystery but also confirmed that our understanding of the universe's evolution was on the right track. Why does it matter? Well, for one thing, it means our cosmic calculations actually make sense. The universe isn't playing tricks on us. Our theories about the Big Bang, galaxy formation, and cosmic evolution are holding up. But there's more. This hidden gas is a crucial ingredient in the story of how galaxies grow, how stars are born, and how the elements that make up life are spread across the cosmos. Because it means our cosmic calculations actually make sense, and this gas is key to galaxy growth, star birth, and well, everything. The WHIM acts as a reservoir, feeding galaxies with fresh material to make new stars. It's also a recycling center where elements forged in stars are blown out into intergalactic space and mixed back into the cosmic web. Without this hidden matter, galaxies would run out of fuel, and the universe would look very different. The discovery of the WHIM also opens up new questions. How does this gas move and change over time? How does it interact with dark matter and dark energy? What role does it play in the life cycles of galaxies? Astronomers are now using new telescopes and simulations to explore these questions, pushing the boundaries of what we know about the universe. The universe isn't missing its matter. It just hid it really well. And thanks to the ingenuity and persistence of astronomers, we've finally found it. The next time you look up at the night sky, remember, most of the universe's ordinary matter isn't in the stars you see, but in the invisible threads that bind the cosmos together. Like cosmic mysteries? Hit like, subscribe, and blast that bell for more. The universe is full of secrets, and we're just getting started on the journey to uncover them. Stay curious and keep looking up.